Okay, so in this lesson we're going to learn how to solve systems of linear equations. And this is kind of a review of previous lessons. In addition, though, we want to determine whether the system is consistent or inconsistent and whether the equations are dependent or independent. Now, the information on determining whether a system is consistent or inconsistent and whether the equations are dependent or independent, that lesson was in a previous lesson. So if you need to go back and review what makes a system consistent or inconsistent, or what makes an equation dependent or independent of the other equations in the system, then go back to the lesson dealing with this. All right, now number one, let's suppose that we had this system of equations. We have 4x plus 2y is equal to 10, and then x minus y is equal to 13. And in this case, let's just go ahead and solve this system by substitution. And so we can do this by substitution. And substitution. Okay, so to solve this system by substitution, remember, you have to get one of the variables by itself and substitute that expression into the other equation. So if you look at this equation, this system, this is the easier one to use first. And then if you look at this, it's easy to get x by itself. So I'm going to go ahead and use substitution by getting the variable x in the second equation by itself. So step one, remember, is to obtain choose one of the equations and get the variable by itself. So step one then would be to use this equation, x minus y equal 13. And then we're going to isolate the variable x. I'm going to add y to both sides. And so I get x equal, combine like terms, this is 0. Now be careful, these are not like terms. They don't say that's 13y. So that's y plus 13 or 13 plus y. Okay, so I'm going to write this as y plus 13. All right, so that was step one. Now, once you get step one, once you isolate one of the variables, and you take this expression right here, and you substitute it into the other equation. So you can go here and substitute into that variable x. All right, so then step two then becomes this. So step two becomes 4 times this expression, which is what x represents, y plus 13. Make sure you put that in parentheses, and make sure you understand that's a y here, plus 2y is equal to 10. And then you solve this linear equation. So I'm going to go ahead and distribute the 4. So I get 4y plus 52 plus 2y equal 10. Combine like terms, I get 4y and 2y, 6y. 6y plus 52 is equal to 10. Subtract 52 from both sides and combine like terms. I get 6y is equal to a negative 42. And so to get y by itself, I'm going to go ahead and divide both sides by 6. And so then y is equal to negative 7. All right, so that's my y value. And remember, you're solving a system, so you have to determine what value for x and what value for y will make those two equations true at the same time. So all you found was y. Okay, so now step 3 is we have to find x now. So find what x equals. So find the value of x. Let's put it that way. Okay, so what I would do is again, it doesn't matter which of those equations you go back to. It does not matter. But if you feel you did step 1 correct, you got to this point, then all I would do is go here, since we're trying to find x. So I'd go back to step 1. Now, again, that's assuming that all this is correct. So if you're not sure, then just go back to one of those equations. But I'm going to go back here, and so in place of y, I'm going to substitute negative 7. So I get x equal negative 7 plus 13, which gives me 6. All right, so x equals 6. So then your solution is as an ordered pair. Remember, x is 6, which you put x first, and then y is negative 7. All right, so that's your solution as an ordered pair. Okay, now, So that's the solution. So there's only one solution. So then the next question becomes, all right, so since I have a solution, is this system consistent or inconsistent? Okay, so remember, this is a quick summary of a previous lesson. So if a system has one solution, now we are talking about a system with just two linear equations. So if a system has one solution, then the system is consistent, and the equations are independent of each other. If a system has an infinite number of solutions, then again, the system is consistent. So a system is consistent if it has one solution or an infinite number of solutions. And you need to be careful, because if it has one solution, then the equations rather, are independent of each other. If it's an infinite number, that means, if you go back to that lesson, that means that the equations overlap. So the graphs are the same. So they're dependent. And then if a system has no solution, then it's inconsistent, and the equations are independent of each other. So the idea of independent and dependent equations, that's a pretty difficult concept for students to understand. Well, why those equations independent versus dependent. So go back to that previous lesson if you need to. All right, but in our case, so we know we have a solution, right? So then the system is consistent. The system is consistent. And the equations are independent. And the equations are independent. Okay? All right, so that was number one. All right, let's look at number two. Let's suppose in number two, I had this. Okay, so let's suppose we had 4x equal 50 plus 2y, and then 3x equal negative 21 minus 5y. All right, so let's suppose we had that equation. Okay, so I'm going to go ahead and do this one by elimination. So let's use elimination. All right, so if I'm going to do this by elimination, I'm going to go ahead and write all these in a better form. So I'm going to bring all the variables to one side and the constants to the other. I'm going to line the variables. So if I look at that first equation, I'm going to have 4x, and when I bring this 2y over, I'm going to have minus 2y. So 4x, so this right here becomes this. So 4x minus 2y equal 50, okay? And then over here, I'm going to get 3x, and then when I add 5y to both sides, we get plus 5y equal negative 21. All right, so that's where I'm at. Okay, so I'm going to go ahead, and it doesn't matter which you eliminate. You can eliminate the x's or you can eliminate the y's, does not matter. I'm going to go ahead and eliminate the y's. All right, so remember, when you eliminate the y's, you need to make sure that at some point you're going to add those, and the variables, the terms y would have to add it to be 0. So I need those coefficients here to be opposites of each other. So in order for that to happen, we need to look at what is the smallest number that negative 2 and 5 will go into, so the least common multiple. And so that's going to be 10, and we need one to be a negative 10 and one to be a positive 10. So I already have one being negative, one being positive. So what I'm going to do is I'm going to multiply this equation by, remember, I want this to have a coefficient of negative 10, so I need to multiply both sides by 5. And then we're going to multiply this equation by, and then this would be 2. Okay? And so then when I do that, I'm going to get this. So I'm going to have 5 times 4x minus 2y equals 5 times 50. So we do what you do to one side, you do to the other. And then the odd one, we're going to have 2 times 3x plus 5y is equal to negative 21 times 2. Okay? All right, so then getting rid of the parentheses, we're going to go ahead and use the distributive property. I get, so this system becomes this. So I'm going to get 5 times 4x is 20x. And then 5 times a negative 2y is a negative 10y equal. And then 5 times 50 is 250. Over here, if I distribute the 2, I get 6x plus 10y is equal to a negative 42. Okay? All right, now the next step is to add. So we're going to add those now because now the coefficients of y's are opposite. So when I add these two equations, the variable y cancels out. So I get 26x, this is 0, equal, and then this becomes 250 minus 42 becomes 208. Okay? And then dividing both sides by 26 and combining up and simplifying, I get 208 divided by 26 is 8. Okay, so the solution, the x value of the ordered pair that makes those two equations true at the same time, the original problem, those two equations true at the same time, the x value be 8. All right, now we have to find, the next step, remember, is to find the value of y. So let's find y. Okay, now to find y, you go back to one of those equations, one of the original, and I would go ahead and use one of the original. It does not matter which one you use. So you can use the first one or the second one. Remember, you found x to be 8, so in place of the variable x, you're going to substitute 8. So let's just go ahead and use the first one. So we're going to find y, so we're going to substitute x equal 8 into that first equation. So substitute x equal 8 into first equation. And so I get 4 times 8 equal 50 plus 2y. 4 times 8 is 32, so 32 equals 50 plus 2y. I'm going to solve this linear equation. So subtract 50 from both sides. And then combine like terms. 38 minus 50 is a negative 18 equal 2y. 50 minus 50 is 0. Divide both sides by 2. I get my y value to be negative 9. So my solution to this system, so the ordered pair that makes the system true, that makes both equations true at the same time, is 8, negative 9. Okay, now since I have a solution, then that means that remember, that means that the one solution, that the system, if the system has one solution, then the system is consistent and the equations are independent. So consistent and independent. So the system is consistent and independent. And the equations are independent, sorry. The equations are independent. Okay? All right, so that was number 2. Let's look at number 3. So number 3, let's suppose we have this in number 3. All right, so in number 3, we have negative 3y plus 6x equal 15. All right, and then the other equation of the system is y equal 2x plus 6. So the way the system's set up, it's easier to use substitution. So we're going to do this by substitution. And the reason, substitution. And the reason is because the variable y is already by itself. So what we're going to do is we're going to take this expression for y and substitute it here into the other equation. So I get negative 3 times 2x plus 6, because that's what y equals, negative 3, and then y, remember, is this right here, plus 6x equal 15. All right, now solving this linear equation, distribute negative 3, I get negative 6x minus 18 plus 6x equal 15. Combine like terms, and I want you to notice what happens when I combine like terms. I get negative 18 equal 15, so the variables disappear. So remember when you solve linear equations in the past, if the variable disappears, you got to look at that statement that you have left. So notice that negative 18 equal 15, that's a false statement. So what that means is that this system has no solution. So the system has no solution. So no ordered pair is going to make this is going to make each equation true at the same time. In fact, if you go back to previous lessons and you were to graph this, those lines would be parallel. So those would be parallel lines and they would not overlap. So the system has no solution. Okay, so what that means then, in terms of that next part of our question, is this. Well, the system has no solution. Then the system is inconsistent and the equations are independent of each other. So the system is inconsistent. And the equations are independent of each other. Okay? All right, so that was number 3. All right, let's look at number 4. Number 4, let's suppose we had this. All right, let's suppose we had y minus 3x equal negative 5. So that's y. And then 4y minus 12x equal negative 20. All right, so I'm going to go ahead and do it both ways. I'm going to use substitution and elimination. So let's just go ahead and use elimination first, just to see what it looks like in both cases. So by elimination, so I'm going to go ahead and remember, with elimination, you got to make sure that when you add those two equations, one of the variables goes away. So one of the variables, so the variable y or the variable x, the coefficients better be opposites of each other. Well, since this is just one y, I'm going to go ahead and multiply, and that's a 4 right here, so the least common multiple is 4. I'm going to go ahead and multiply this equation by negative 4. All right, so then this becomes this. I'm going to say negative 4 times y. What you do one side, you do the other now. So you got to multiply both sides of that equation by negative 4. And then we leave the other equation alone, so I'm not going to do anything with it. And so then this system becomes this. So that becomes, if I distribute, I get negative 4y plus 12x equal 20, right? And then over here, I get 4y, the second equation, I didn't do anything with it, equal negative 20. Now, when I add these up, I want you to notice what's going to happen. When I add these, the variable y, when I add them, that's 0. The same thing for x, right? So this side, 0 and 0, 0. On this side also, what do you get? You get 0 as well, right? So that goes back to that previous problem where we had the variables disappear. So when the variables disappear, there weren't any variables left. And you look at that statement, that's a false statement. Negative 18 will never equal 15. So then we said the system had no solution. Right here, when we solved this system, we had 0 equals 0. The variable disappeared, and that statement is a true statement. 0 does equal 0, so that's a true statement, right? So in previous lessons, you learned that when you're solving an equation and the variable disappear, and you have a true statement, then that means that any real number is a solution if it were a linear equation. But we got to be careful. This is a system. All right. So in a system, you're dealing with ordered pairs. So not every ordered pair. When we say there are an infinite number of solutions, that doesn't mean that any ordered pair works. Okay. So you got to go back to our lessons that talked about that. So it is correct to say that this system has an infinite number of solutions. The system has an infinite number of solutions. All right, now it also means that if you were to graph this, the lines, if you were to graph it, that those two lines would overlap. That's what that means. Okay? So that's what that means. So go back to our lesson previously and you'll see what we're talking about. So those two lines overlap. So we have one line, then we have the other line that when we graph it is the same line. So those two lines overlap. So how many solutions are there? They're an infinite number. Okay? Now when we say there are infinite number of solutions, that mean that every ordered pair in this plane is a solution? No. Only those ordered pairs that's on this line. Okay? All right. So when we say there are an infinite number of solutions, that doesn't mean that means that any ordered pair works. Only those ordered pairs that's here. That's on these two lines, which is the same graph. Okay? All right. So it is correct to say this statement. That's a true statement right here. Okay? So since the system has an infinite number of solutions, that means that the system is consistent, but the equations are dependent on each other. All right, so the system is consistent, and the equations are dependent. All right, now let's go back and have our discussion again. So we have these two equations. We had two equations, and since they're an infinite number of solutions, that means that if we were to graph those equations would overlap. So those are where the solutions are. So remember, in a previous lesson, you had to actually state what the solutions are. So since there's an infinite number of these solutions, the way we did this was this. All right, so you may be asked to do this. So you may be asked to go beyond just saying there are an infinite number of solutions. All right, so the solutions have this form. So the solutions are of the form. And remember how we did this. We said this. So solutions are of the form. And we said, and remember they're an infinite number. So we said the set of ordered pairs xy, such that, and all you do is just pick one of these equations, because the equations, either one, remember they're dependent of each other, right? So it doesn't matter which one you use. Those ordered pairs are going to have that form, whatever that equation is, either this one or the other equation, because the solutions of this equation, the solutions of that equation are the same. So all you have to do is say this, of the form, and just you write one of the other equations. Y minus 3x equal negative 5. So that's one way you can write it. You could have chosen the other one, right? Or you could have said the set of ordered pairs xy such that, and then choose the other equation, 4y minus 12x equal negative 20. So the point being this just saying, depending on how they're asking you, just saying that it has an infinite number of solutions is not enough. They may ask you to determine or to state what form do the solutions have. Well, the solutions are any ordered pair that satisfies this equation, or any ordered pair that satisfies this equation. Okay? Doesn't matter which one you use, because whatever ordered pair is on here is going to be on this one. Okay, so that was a discussion on how to determine whether a system is consistent, or whether the consistent, or whether the equations are independent, dependent, based on the solutions of our system. Okay, so that's going to be the end of this lesson.